All right, hi everyone. I know you've been living in suspense here on why is this thing a circle, so let's quickly figure out why that this is true. So remember, we're trying to graph this r equals 2 sine theta, and my claim is that it's going to be a circle. Okay, so let's see why. Let's zoom it in. All right, so this is the function that we were given, r equals 2 sine theta. Let's look at r squared. I'm going to do this kind of silly. So I'm going to have 2 sine theta, that's 1r, and then just times r. So I'm going to write it like this, 2r sine theta. Okay, however, this r sine theta equals y. If you look at back to what the converting from Cartesian to polar. Okay, so we get that. All right, however, we know that r squared equals x squared plus y squared, also because of that conversion factor. So we have this equation. Now, don't worry, we're not going to have to look at this we're not going to really have to replicate this so many times, but it's just really to show you the claim that this thing is a circle. So we have this moving the 2y over. Let's complete the square. Okay, so we got x squared plus y squared minus 2y. If you remember how to complete the square, we're going to add 1 on both sides, and that's because it gives us the really nice thing of x squared plus, and then this thing with the y's is a perfect square. If you don't believe me, expand that out. And this is actually the equation for a circle. And actually, you can say something about that. The center, I have that it equals 0. Really, it's equal to 1. Sorry about that. So our center is 0, 1, and our radius is 1. Okay, remember you can write any circle in the form, usually they say x minus h squared plus y minus k squared equals r squared, where hk is your center and r is the radius. And so you see that that's all I did there. That's how I found the center. That's how I found the radius. All right, and then where was our center? Our center is, remember the radius for, well, this was 2, so this is 1 here. This is 1, and this is the point 0, 1. And there we go, it is a circle. All right. Now, what was so special about that? Well, we could really look into graphing other functions. So let's try that. Our next function that we're going to work with is r equaling 1 plus cosine theta. Now, if you remember, we kind of want to know when when is r greater than or equal to 0? Remember, because there is some special directions if r was negative. So here we go. We want to figure out when it's bigger than or equal to 0. Let's see. We know some fact about cosine, right? It's between -1 and 1. So we know that fact. That's almost what we have here, except where we need to add 1 on the inside here. So we're going to add 1 on each portion of this inequality. So if we add 1, we get 0 there. We get 1 plus cosine theta, which is exactly what r is. And then on the right, we get 2. So we get r is between 0 and 2. So therefore, thus, it's always positive. or we should say always non-negative here, because it could equal 0. Negative. There we are. So that's 1, and now we can graph it. Okay, so your favorite, we're going to make a theta r chart. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so we got 1 plus cosine 0, which equals 1 plus 1, so 2. 1 plus cosine pi over 2, so we just get 1. 1 plus cosine pi, we get 1 minus 1, so 0. 1 plus cosine 3 pi over 2, and we get 1 again, and then 1 plus cosine 2 pi, and we're back at 2. So let's try to graph this now. Okay, remember, we got our different lines here. Theta has to deal with the angle from our positive x-axis, and r is the distance you go out. Okay, so when we're at theta equals 0, we have to go out 2. So let's make it real nice since we got this graph paper. So we're going out 2 there. When theta is pi over 2, so we're up here at this line, the theta of pi over 2 line, and we go out 1. So there we are. When we're in the theta equals pi line, we go out 0. When we're at the theta equals 3 pi over 2 line, we go out 1. And then when we're back at 2 pi, we go out 2 again. So we're back at that point. All right, so here we go. Now everything's nice and smooth, and believe it or not, this is the shape that we get. And then it goes back to this point, and then over here it's nice and positive, and goes out like this. All right, so does that look familiar? It should remind you of Venus and Earth, the first time that they go around. And then they end up making 5 of those overlapped. But this is what we call a cardioid in polar coordinates. You guys know why? Nice, it looks like a heart. There we are. Okay, so it's a cardioid. Actually, a cardioid is going to be of this form. You're going to have some number, so like 1, and then plus a trig function, so like cosine or sine. Okay, and then there's another one that I want to focus on. All right, and this one's going to take a little while to do. So we'll get started, and then we'll have to go to the next video. So our next example is going to be r equals 3 cosine 2 theta. And if you remember, it's not going to be a cardioid because it's not some number that's not 0 plus a trig function. So first off, we want to know when is r greater than or equal to 0. So we just set r greater than or equal to 0. Okay, so dividing by 3 on both sides, we get cosine of 2 theta over 2 theta greater than 0. So when does this happen? So remember our discussion the other day. Oops. There we go. So cosine's going to be positive here and here. However, it's a 2 theta. So that's going to make things a little bit different here. So let's look at this. So whatever's in the middle, we're going to, so this 2 theta business is throwing it off. If it was just theta, we know that it's in these two quadrants. But what happens when it's 2 theta? So, all right. So this is like what the first quadrant is, right? The first quadrant is between 0 and pi over 2. And we want to know our angle, though, now is 2 theta. So let's get theta by itself. So we're going to divide everything by 2. Left side's easy. This one's just theta. And then this becomes pi over 4. So this is our new first quadrant. Okay, so basically what's happening real quick here is that we're taking that first quadrant, that first blue quadrant, and making it just go to pi over 4. Okay, so you can think of that as quadrant 1, and then this next one, it's still going to be quadrant, well, here it's quadrant 2. So we're just breaking this into different quadrants now. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, quadrant 1, 2, 3, 4. So basically with the 2 theta, it's like you're going around twice. Okay, so we know cosine's positive in quadrant 1 and 4. So we know it's going to be positive here and at 4 and at 1 and at 4 again. So that's when R is positive. It's in that blue area.